All right, now we're ready to go into basically the next level. I've had a good night's sleep. It's lighter in here. It's a beautiful thing. We're gonna go to the next level, and I'm gonna show you a neat trick. All right. So it's a new day. So let me just go to our links up here, and I'm gonna find the textbook right there, and then in we go, and I gotta log in, of course. That's awesome. I probably should have done that before starting, but you know what, it's okay. There you go, there's that. And I think that is it, right? Here we go. Look, he's waving at me, so maybe it's it. All right, good. All right, we're going in. Yay, we're in. All right, let's continue reading. Where did I leave off? So apparently I left off at a blank page. No, there it is. All right, so we started this madness by going through the first thing, which was a straight sequential code of toast, right? And that basically got us this program here. And again, this is an idle. And for goodness sakes, if you haven't done it already, definitely type this up, get it working, either in idle. You could, in theory, do this in, speaking of that, either you could, in theory, get this working in the cloud Python shell, or where I've been going and will be going again is Python anywhere. All right, so back to this. That was our first program. Straight sequence, boom, 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 boom. I don't have the charts up, but basically this was, a straight, almost like a spine. Then we go to the next guy, and this is the whole gluten-free. If, once you start seeing words like if popping up, if this, then that. And so what we had here was a program which I sort of talked through last time, felt like last week, but just yesterday, talked through this program here. And it did introduce a couple of ideas. Of course, I didn't actually review those other ideas, but anyway, here's the deal. This is a comment. The comment is meant solely for the programmers or future people looking at the code. It's supposed to help explain what you're doing, who wrote it, when they wrote it, that kind of thing. Then we have prints. Prints were functions. They basically took in input and returned out on the screen output. So this thing here about print selection algorithm, what we see here is selection algorithm. That basically it's printed to the screen. Okay, I'll talk about that in a minute. Okay, then we actually have a variable, and I'm going to show you that's my neat trick today, by the way. It's going to show you how you can actually visualize variables and what's actually going on with the variables. This variable here is a piece of memory that's held by this particular program, and in it, it's got a Boolean value false. We're gonna look at three types of variables in this next program, and some variables can be numbers, some variables can be strings, some variables can be Boolean. Booleans are true or false in this language, and in other languages, it can actually be true, false, or unknown. And so that's what's going on there. We get basically a variable, and it's hard coded. That's the other idea I brought up last time. We have coded in there false. And then we have this structure here, which is an if-else structure, an if-else structure. So if this is true, and if you remember, I showed you in that video, I had the two equals. This is an assignment. False is assigned to the variable. In my program example, which I'll be showing you something like it in a few minutes. So if you don't know what I'm talking about, don't worry about it. But I basically had two equals and then true. So that's a condition. And if that ends up being true, then this block of code runs. Otherwise, this block of code's run. And then you can tell by the fact that this is not indented that this basically is going to run regardless. It's outside of the condition. All right. I did a slightly different version of this because I noticed that there were some things like pushing the toaster level and getting toast. You could argue maybe that's not the same because this is gluten-free toast. But anyway, getting a pushing the toaster level, getting the toast, those were common to both branches of the condition. So I had them outside. All right. One other thing I didn't bring up is what the heck that was. And what you'll notice is that what that basically means is new line. And it's actually a special character. If you see something in the codes, it's got a slash and then a lowercase letter. It's basically saying to do something in the string that's mostly for the presentation of it. So the two most commons are /n, which means new line, and /t, which basically means tab. All right. There's a few others, but that's good enough. And so that's why we get a blank line right there. We have this, if you look at these guys, there's no slashes, and it's straight one line after the other. But yet here we got these two. Why is there a blank line? There's a blank line because /n says print this new line, then the print function finishes, and so the next print function starts with its own line. All right, great. Now, that's quite a jump. That is seriously quite a jump from the previous program. If you look at the previous program, although I guess the /n was there too, but if you look at the previous program, we got a bunch of prints, we got the comments, and now all of a sudden in this program on 2B, what we're starting to see now is we're starting to add variables, assignments, Booleans, and conditions. Wow. Let's go look at the next program now. Now, the next program's got a lot of stuff going on here, and I want to absolutely make sure that we address all of this. Some of the stuff is going to get a better explanation later on down the course, but I think sometimes it's better to talk about programming while programming. So when I'm looking at this, I think what I'm going to do is I'm going to build a very simple version of this program first. And what you can see, if you just look at sort of the requirements here, it's ultimately trying to basically, oh, by the way, what is this? It's for marathons. Now, they didn't give us any pseudocode to look at, but it looks like it's basically a variable or a program here that's talking about fundraising for a 5K marathon. And someone, if we look at the output, they're going to basically put in their name, maybe how much they contributed, and then the way I understand about marathons is that there are tags apparently stuck onto the person's right there. So there's a tag stuck on their t-shirt. All right. So I'm going to come at this slowly in a way that will help us try to understand what's going on in this program. And so for this, again, I'm going to fly off and use my Python Anywhere. And for my Python Anywhere, what I'm going to do is I'm going to, in my case, I'm going to go browse. I'm going to go to chapter 2, my directory, and I'm going to create a new program. If you want to use idle for this, 100% cool, right? Not a big deal. Review how I used idle before. All right, so this guy here, I'm going to name it after the program. So it's basically example 2C. Sure, 02C. .py. I have to do the .py here. I wouldn't have to do that in idle. So I think it might help if I just basically have the beginning of this, which is going to be print. Let's get close to what that line is. That is basically, thank you, blah, for contributing to that. Your tag is this, enjoy the marathon. All right, so thank you, Grant, for contributing to the marathon, we'll say at this point, $100 to the marathon. Your tag is, I would definitely be walking 1,000. All right, what a great little program. It's basically a hello world program. I'm going to run it right now. It's going to run, and let's just now test my console down here. And hopefully what I get is a nice little print statement. Boom, there it is. Great. And I tell you what, let's use some of that new knowledge we just did. I would like this to be on its own line, the your tag part. I could, in theory, just do another print statement, but no, I'm not going to do that. That's just stupid. What I'm going to do instead is I'm going to go /n, because I just learned that. I'm going to, and notice the /n even is a different color in this interface. And I'm going to go run, and now you'll see my tag is underneath there. Great. But wait a minute, That's all hard-coded. Now, what if Sam wants to use the program? Is Sam going to have to go in here and change this and change this and change his tag? No, I don't think so. I think in this case, we can start to have some variables. And we're going to have a variable here. No, actually, should I do this now? How does, yeah, he does. All right. Tell you what, right now I'm just going to go variable name, which is going to be assigned Grant. Grant is a string. All right. I'm going to have a variable called contribution. That is going to be 100. I'm going to have a tag, which is going to be, yeah, tell you what, it's going to be another string, 1,000. Good deal. Now I'm going to run this. Good deal. Great. Now let's talk about how would I use these variables inside this string. So a couple cool things. There are actually a few choices for this. And now I'm not forgotten if I've mentioned this, so I'll just say this again. This is a string. This is a number. These are variables. This is a variable called name. Let me show you now how this would actually run. I have put out there for you guys a Python visualizer. This does not require login information at all, but what you can do if you want is take your code, copy it, paste it into here, and run it. You can visualize its execution. This is still very much of a sequence. Do this, do this, do this, do this. It's very much of a sequence. So I'm going to go visualize. And so what you get to see is here's your code on the left. Here's what's going on in the memory of the cloud, in this case, in the memory of Python. So if this was running in idle, well, actually, one step back. If you were running a Word, you were typing out your resume, for example, in a Word document, understand that, of course, when you open up Microsoft Word, it's going to grab some of the memory of your laptop, we'll say, and then dedicate some of that memory to your resume. So as you're typing, it's remembering what you've done, right? And then when you shut that resume down, Word still is occupying memory, but now it's no longer thinking about your resume, right? And if you shut Word down, then that all is all freed up. And you can actually see your memory thanks to most modern computers right here. Like right here, you can kind of see that Discord is using some memory. My Chrome, the browser, this manager itself is using some memory. All these things are using bits of my memory. And then as I start to shut some things down, let's just do that. Boom, it releases the memory, right? And I'm actually considering how little, well, I guess I can imagine Zoom is probably occupying it. But anyway, so this is some of the stuff that's using the memory. And now what this visualizer does is it kind of in here shows you what is going on in the Python's memory, which is kind of like nothing at this point, because we are just about to execute that first line. So now I'm going to go next. And so now in the global memory, and we'll understand more about what that means as we move further in time. But for now, we'll just imagine this is the memory of Python, the global memory of Python. Global, yeah, I don't want to talk too much more about it for now. Just imagine, it's basically the memory of Python. We got a variable called Grant, and it now has this string of characters, this string in memory. I then go next. So now we've just executed that line. And so we can see there's contribution at 100. And I go next. Now tag is in there. I go next. And it's printed. And now we're finished. Right? We are now finished. So not the most exciting program, but I want you to see that is the stuff that's in memory. And you can tell it's still in memory even here, because if I was to go back now and say in this environment, print name, yeah, excuse me, wrong syntax, print name, it's still in memory, okay? So, so the visualizer is not lying here. This stuff is still in memory. We're just not doing anything with it anymore. Okay, so now that we got that kind of idea, let's go back into here and let's use these variables. So I don't want to have Grant here. I want to have whatever name I happen to put up on line 1. That's what I want to have. So what I'm going to do is I'm going to break the string up. And I tell you what, we'll do it this way, comma, name, comma, oops, excuse me. The language I'm mostly used to dealing with strings with has single quotes, but I want to use double quotes for this. All right, so here's the first string, thank you, comma, then the name, comma, then the rest of the string. Okay, so we go run it first of all. Is it going to work? Yes, it's going to work. And now I basically used Grant. Notice that it's got a character here and a character here. What's going on? Well, by default, the print statement, when it's putting strings together, if you're using a comma, it's going to put a space between the two. Now, there is another way to do this, and let me just quickly scan to see if that's what they did here. Yes, they did do that, so I should definitely talk about it. There is a different way to do that. Oops, skip back. And that is to go add. You can, in theory, add a string. Remember, all this stuff, well, it's kind of like math. So I can basically add, right? I'm going to go run. Now, what's the difference? The adding doesn't give you a space. You have to basically put the space into your strings if you're going to add it. Which one should you use? It really depends on what you feel like doing. That's the answer to that question. It feels like what you should be doing. But now we can go a little bit further now. So let's go. We just added this. Now let's go ahead, and it's not 100. We want to make that also the number here. So I'm going to go. Double quote plus contribution. By the way, at this point, might want to think about going onto my own line here, plus, and then double quote. Let's make sure that this thing still works. And it doesn't because an interesting problem. So I can add a string to a string, but I can't add a number to a string. And that's kind of what it's saying here. Now, I said add. I think you're grown up now for this. We don't really add strings together. You actually concatenate. That's the fancy word for adding strings together. You concatenate together. So, so in this case, I cannot concatenate a number to a string. And that's kind of what it's basically saying there at line 5. So for now, let's take a shortcut so I don't completely blow your minds and make it a string. And let's go, but we are going to fix this. Okay, I forgot my space. And then the tag is the same thing. So let's add my space plus tag. There we go. All right. That would be a good thing for you to do. So I would, if you haven't been doing this already, I would pause and get something like this working, because we're about to go sort of to a next step here. All right. So pause. I'm waiting for you. I got nothing else to do. All right. I'm assuming that you've got this thing working. All right. So let's fix this problem. We can't have everything being strings. We are going to have to basically take this 100 and make it work. You're not going to get too far if you got to basically constantly keep things all the same. Like the whole program can't be strings. The whole program can't be numbers. You're going to get these combinations where you're trying to basically deal with strings and adding them to numbers, or you're going to take numbers and concatenating them to strings. It's going to be a thing. So you're going to want to try and figure this out. So there's a couple things we could do with this, but what I think the preferred way at this point would be to use another function. Now, don't freak out. You've been using a function the whole time. You've been using the print function. But now what you want to do is we're going to add another function in here. We're going to add a function that actually converts this to a string. And we do actually see that in this program. But for now, we'll just leave it. str will be a function. And what it does is it takes in a numerical value and converts it to a string. Then at this point, this string will be concatenated to this string, all right, and the string that follows. Let's run that, make sure that works, and it works. And so now we've got ourselves a nice little program. If I decide I want to change this to $1,000, I'm going to go, and now I'm now contributing $1,000 to a marathon I would never in my life run. I think, by the way, Sam and Steve Dupay, the other author for this book, are marathon people. I'm not, but that's fine. I'm going to bring it down to $10. I'm going to go. Right? It's working like a charm. So a learning objective here is we got variables. We're now adding them into one big string. We're actually doing some conversion, or another way to say this is also casting, but we're basically taking one thing that's a number and we're making it into a string. You don't do this next thing, but I could have done that casting up here, right, at the source of input. I could have done it there, and it's got no problem, by the way, because now this guy has become a string, and now it just basically further converts it to a string. By the way, I tell you what, no, we're going to leave it like that. Okay. All right, that was a pretty big deal, and it will show up in that program, so that's why we're going to look at it there. Look at it here. Can we now get a little bit more real and say, okay, Grant, every time you run the program, do you really have to go into the program and change the variables? And the answer is no. That's pretty gross. We can actually use another function. We can use something called an input function. So watch this. I'm going to take Grant. I'm going to remove Grant. I'm going to go input, just like that. Input, and you can tell from its parentheses, it's functions. Print's a function because it's got parentheses. String is a function. It's got parentheses. This is also now a straight function. I'm not even going to bother to put anything in it. By the way, a long time ago, you may have seen me do this too. Exit, except I spelled it wrong. Exit, that's also a function too. All right. So anyway, let's run this guy with input. We're going to go. Now, it's waiting for input from me. If I decide to type in Fred and hit enter, I've now got thank you, Fred, for contributing $10 to the marathon. If I run it again, it's waiting for input from me. If I go Alice, thank you, Alice. Do you see that working? Now that's pretty cool, but I can't imagine being the poor sap that's trying to run this program and going, well, what am I supposed to do now? We kind of need to prompt the user along and say, hey, this is what I want you to do. Okay, so let me get out of this now. By the way, if I hit enter, thank you, nobody, for contributing $10. So the prompt is the input to input. So I'm going to put a string saying, what is your name? All right. What is your name? I'm going to go. And now, instead of blank, I've got what is your name? And of course, it's waiting for me right there. Now, a little bit of something smoother here. Some things I like to do with prompts, you don't have to, by the way, but I like to kind of make sure that people understand this is a prompt. So I'll put like something in there, and then when I run it, you know, it basically says, what is your name? And now the person knows that they're supposed to type, you know, Grant, something like that. You know, I like to do those kind of things. Whatever, right? Some people put colons. We're actually going to see prompts popping up in that particular code, like right there. You can see that the authors use colons. That's fine. Good deal. All right. Now that I've done a prompt, let's quickly run this thing to the visualizer and see what the visualizer does with that. So we left this now with a pretty sequential code. I'm going to end. It's now basically saying put your code in. I'm going to go paste. All right, so we got the input, we got the contribution variable, we got the tag variable, these assignments, and then we got the print. I'm going to visualize the execution. Notice that the prompts pop up down here. Or I should say the input function is resolved right here. So what is your name? So if I put in Bugs Bunny and I go submit, bang, now in the name variable is Bugs Bunny. And now it's about to run the rest of the program. And we are done. Pretty cool. All right. So prompts show up here. It's not as obvious if you're trying to test your code, but that's what's going on. Cool. All right. So let's do the rest of this. Let's add some more prompts to the rest of this. So I'm going to basically start going inputs, and we're going to go input there. I'm going to put an input here. I'm going to say, how much are you going to contribute? Use the Grant Spencer patented prompt indicator there. And here I'm going to basically say, what is your tag? All right, let's go. What is my name? Grant. How much am I going to contribute? $100. What's my tag? WD40, whatever. Cool. Now, I should point out that the input function returns a string. All right, it does return a string. So in this case, contribution, it's going to get a string anyway. So you know what we can do here is we don't really need that function smoothing things up there. We can kind of just let this continue to be a string. And now we're going to go and run that. All right, so now I'm going to go Grant, and I did that wrong, but whatever. A lot of money, and I don't know. All right, so there you go. That's there's some pretty cool stuff going on in this particular program, and we're not even close to getting some of the magic that's actually happening here. So I think, was there one more variable I need to deal with? That's the tag, that's the donation. All right, let me also take a minute here to talk about something that they are doing quite a bit in the textbook, which is a good practice. When we're looking at int tag, you'll notice that they have int tag, but I have just tag. What they're doing there is they are trying to communicate to anyone looking at the program what is the data type of these variables. So for example, this really should be str name, because that's, oh, geez. This really should be str name, because it's a string. This really should be str tag, because that's a string. And this should really be str contribution, because that's a string. And then what I need to do is go and make sure that I have updated my program to run with the appropriate variable names. Because right now, I know that everything, is a string. So they basically put the data type in front of the string. Okay, Grant 100 and W1000. All right, so that's kind of an important convention, standard, that's it. It's kind of an important convention or standard that they are doing in the textbook, and they're doing that in the textbook because we actually do that in industry. So I'm going to try now to continue doing that. I think I'm going to end this video now, and then I'm going to pick up again as we go to the next level, because There's still actually some interesting dynamics just in the straight sequence, and then we'll talk at that point about some of the selection and then the iteration. All right, so definitely, for goodness sakes, get that working on whatever platform that you're actually using. All right.